You know, for the last couple of decades, we've been riding this incredible wave of data, a complete explosion of it. Weblogs, social media, scientific data, you name it. The sheer amount of information got so huge that our old ways of doing things just completely broke. So we got smart. We built these amazing, brilliant solutions, frameworks that could actually handle petabytes of data and find real insights in all that noise. But what happens when that amazing solution starts to become the new problem? Let's get into it.
And that right there is the paradox we're going to dig into today. Those very same game-changing solutions, the ones built by giants like Google, Facebook, and Amazon, well, they're starting to hit a wall. The core idea that made them so incredibly powerful is now turning into a massive bottleneck in our super-connected global world.
Okay, so to really understand the problem we're facing now, we first have to go back and appreciate just how clever the original solution was. It totally changed the game for computing, and it was all built on one really powerful idea. Get all your data into one central place and then process it.
The hero of this first chapter is a model that came out of Google way back in 2004. It's called MapReduce. And it was an absolute game changer because it hid all the messy, complicated stuff from the programmer. Things like parallelization, which is just a fancy way of saying do a lot of things at once, and fault tolerance, making sure the whole system doesn't crash if one computer dies. All that complexity was tucked away inside a simple library. At its heart, the model is beautifully simple. Imagine you have this giant central kitchen. The first step, the map task, is like having thousands of chefs all chopping up ingredients at the exact same time. They take all this raw data and break it down into standard labeled pairs. Think of it like labeling a bin onions, and then all the chopped onions go in there. Then comes the second step, the reduce task. That's like the head chef coming along, grabbing all the bins with the same label, all the onions, and combining them to cook the final meal. And believe me, this model took over the world for a reason. It could scale to almost unimaginable sizes. It was super resilient. If one server went down, another one would just pick up its work, no big deal. But best of all, it made life so much easier for developers, and it was cheap. It ran on huge clusters of regular, off-the-shelf computers. For a long time, this was, without a doubt, the king of big data. But here's the twist. While we were all busy perfecting this awesome centralized model, the world itself was changing. Data wasn't just being created in a few big places anymore. All of a sudden, it started being born everywhere, all at once.
And this is our new reality. You've got climate sensors scattered across every continent. You have huge companies with offices and customers in dozens of countries. You've got social networks with users all over the planet, and massive science projects like DNA sequencing happening in labs from Boston to Beijing. The data is what we call geo-distributed, right from the moment it's created.
So why is all this happening? Well, it really boils down to two main things. First, business is global. It just is. Companies need data centers all over the place to be close to their customers. And second, to make sure things are reliable and secure, a lot of companies now use a multi-cloud strategy. They spread their data across different providers like Amazon, Microsoft, and Google. Basically, the data has to live where the business lives.
And this is where we hit the wall. That fundamental assumption of the old model that you can just easily move all your data to one central spot is completely breaking down. The very thing that made it strong is now its biggest weakness. What used to be the solution is now the bottleneck.
Okay, here is the absolute heart of the issue. The speed at which we're creating data all around the globe is growing way, way faster than the speed of the networks we use to move it. The growth in network capacity just isn't keeping up. It's not even close. And that's creating this massive and growing gap.
Let's just put a number on that to make it real. Between 2011 and 2015 alone, so in just 4 years, the demand for network bandwidth basically quintupled. It jumped from 60 to 290 terabits per second. The infrastructure just can't keep up with that kind of growth. Trying to ship petabytes of data across oceans is becoming physically and economically just about impossible.
And you know what? It's not even just about speed. There are other huge hurdles. You've got massive security and privacy concerns. Different countries have different laws about where data can even be stored or processed. The network costs to move that much data are absolutely astronomical. And here's the real kicker. A lot of the time, the final answer you're looking for only needs a tiny little fraction of all that raw data you just spent a fortune moving.
So all of this forces us to ask a really fundamental question. If bringing all the data to one place to do the computation is broken, then what's the alternative? Well, the answer is as simple as it is revolutionary. You bring the compute to the data. Instead of trying to move these mountains of raw information, you send the small, lightweight analysis code to wherever the data already is. And that simple flip is the paradigm shift that is changing everything about big data.
This new model completely flips our kitchen analogy on its head. Remember the giant central kitchen? Forget that. Now, instead of shipping raw ingredients from farms all over the world, you build small, local kitchens right there at each farm. They do all the prep work, the initial cooking, and then they only ship the much smaller finished meals to a central spot for the final plating. And the advantages here are enormous. You can share resources and balance the load across the entire globe. You can scale clusters up or down in the middle of a job. You can save a ton of money by running your analysis in whatever cloud region is cheapest at that exact moment. And you get much higher fault tolerance. I mean, if an entire data center goes offline, the whole system can just keep on running. But of course, there's no magic bullet. This powerful new approach isn't a free lunch. It solves the massive data movement problem for sure. But in doing so, it creates a whole new set of really complex, really interesting challenges that researchers and engineers are trying to solve right now. So this is kind of the new to-do list for engineers in this space. They have to solve these incredibly complex puzzles, like data locality. Is it always better to process the data right where it is, or should you sometimes move it to a data center that's nearby but has more power? They have to figure out task assignment. Which of your data centers around the world is the absolute best place to run this one specific task to get it done the fastest? And of course, making sure data is secure as it moves and that your code can work everywhere are still huge hurdles. And that leaves us with the big question for the future of data. The ultimate solution isn't just about optimizing one of these things. It's about building a system that can optimize all of them: task assignment, data locality, network speed, security, all at the same time, in a world that's constantly changing. The teams that crack this code won't just be solving a technical problem. They'll be building the foundation for the next generation of global intelligence.